Good afternoon to everyone. Myself, I am Dr.RNA Prasad from the Department of Physics, anrcollege, Gudivada. Today, we are going to learn about the lasers and its applications. The main contents consists of 9 parts. Number 1, the introduction. Number 2, the principle of lasers and how the pumping that should be done in different manners, and types of lasers. Among the types of lasers, especially here we are considering about 3-level laser, ruby laser as an example, and the 4-level laser system. Here we are dealing with the helium neon laser. After that, it was followed by the applications of lasers, especially in the communications, industry and medicine, as well as the military purposes. And the 7th one was the advantages of using lasers, and the 8th one was the disadvantages, and finally it follows the conclusion. About the introduction of the laser, we are all well known that the laser is a word which stands for light amplification by stimulated emission of radiation. We are having different features when compared with the ordinary light. The lasers are essentially, they are high directionality and high intense beam they can produce, and they are highly monochromatic, and they are highly coherent. Basing on the stimulated emission concept, in the year 1917, the Albert Einstein, it was postulated stimulated emission, and the prediction was put to the practical use by the scientist named as C.H. Towns and his co-workers in the year 1954. After that, in 1960s, the first solid-state laser was invented by the scientist Maimon, which is known as the ruby laser. It emits the red light in a wavelength region of 6943 angstroms, and in the next consequence year, 1961, a gas laser named as a helium neon laser developed by the scientist Ali Javan and others in the Bell Laboratory. It emits the visible light in the wavelength region of 6328 angstroms, and in the IR region 1150 nanometers. Before going to discuss about the ruby laser and the helium neon laser, first of all, let me know what was the principle behind the laser light. We are all well known that the atoms are in the ground level. In order to excite the atoms to the higher energy level, we need to give some energy. So, if we observe, all the atoms are in the ground level. If we give the suitable energy to the ground level atoms, then they are all excited and reaches to the exciting level. The process of absorbing the incident radiation energy and moves to the higher energy level is called absorption process. When the electrons reaches to the higher energy level, they are not stable. They definitely moves down to the lower energy level by giving the radiation which was already emitted while it was in the exciting level. So, without the involvement of the any photon having energy is equals to h nu, the excited atom itself comes to the ground level. That emission is called spontaneous emission. Of course, we are already having a few of the atoms in the excited level. If we give the photon having energy is equals to h nu in the ground level, then the exciting level atom that will comes to the ground level by stimulating the another atom which was having in the same mode. It was called as the stimulated emission. So, the main principle of the laser emission is based on the stimulated emission process. Why? Because the emitted photons, they are all good in phase with the incident photon, and at the same time they are all the coherent. Here the process of exciting the atoms from lower energy level even to the higher energy level E2 itself called as the stimulated absorption of radiation. If we see in the diagram the atom in the ground level which was at the E1 level. E1 is the lower energy level and here E2 is the higher energy level. If we incident a photon having energy h nu on the ground level atom, then it absorbs the energy and reaches to the exciting level. So, it was reaches to the E2 level. So, this process is called as the stimulated absorption of radiation. But the excited atom on the excited level, they are not stable and they comes back to the ground level by giving the energy in the form of radiation. So, without the involvement of the any other photon, the excited atom itself comes back to the ground level. So, this type of emission is called as the spontaneous emission of radiation. The excited atom, after getting stimulated by the another incident photon from the lower energy level, so then the exciting level atoms, they comes back to the ground level which will be equals to whose energy is equals to 2h nu. So, here in the exciting level, the atom that was stimulates the another photon that was travels from ground to the higher energy level, that comes back to the ground level. So, this process of emission is called as the stimulated emission of radiation. The main condition for the laser operation was the population inversion. Of course, if we see the diagram, before excitation process in the lower energy level E1, the number of atoms that are being present in this level, let it be some M1, and in the excited level the energy was E2. So, if we observe from the figure, it was clear that N1 is greater than N2. That means the number of atoms in the ground state are more when compared with the exciting level. So after some time, the number of atoms in the excited level, they becomes more. So the population, that means the total number of atoms in the ground level, they are more when compared with the ground level. So the exciting state consists of more number of atoms when compared with the ground state. So that's why N1 is less than N2. So here the number of atoms in the excited level, they are more when compared with the ground state. So this process is called as the population inversion, and the main principle that was involved behind the lasing action was the population inversion. First of all the atoms must be population, they must be populated to the inverse sense, and then after the lasing action will be taking place. So here we are the process of moving the atoms from lower energy level to the higher energy level, that process is called pumping. And of course we are having different methods for pumping. Among them, we may achieve the population inversion by using lamps of having appropriate intensity, and we may also obtain the population inversion by the electrical discharge. We are having different methods for achieving the population inversion, and I have already told you the process itself called as the pumping. So among different types of pumpings, the first one was an optical pumping. The better example of optical pumping was the ruby laser, and the second one was the electrical discharge, which was used in the helium neon laser. Just we are going to discuss in the later. And the fourth one was the direct conversion, which was used in the semiconducting laser devices. And the last one was a chemical reaction. So it was used in the carbon dioxide laser. Here in this slide, we are showing how the lasing action can be taking place. If we see, this was the diagram which we already seen in the stimulated emission process. After the population inversion was achieved, then the electrons from the ground level reaches to the higher energy level. They stimulates the excited electron or excited atom. They comes to the ground level, and here 1 becomes 2, and 2 becomes 4, and 4 brings to 8 electrons out from the exciting level to the lower energy level. And now the multiples of 2 power 0, this one 2 power 0, this was 2 power 1, this was 2 power 2, and later it was 2 cube and 2 power 4, and so on. So in this way the lasing action can be taking place. We are having different types of lasers basing on the technological needs. Among different types, the first one was a solid state laser. The better example of solid state laser was a ruby laser, and the second one was a gas laser, which was a helium neon laser, can be treated as a gas laser, and CO2 laser, argon ion laser is also treated as a gas lasers. The third one was a liquid laser. A fourth one was a dye laser, and fifth one was a semiconductor laser, gallium arsenide laser, etc. For our time being, here we are going to discuss about the solid state laser and the gas lasers. The first one, a ruby laser. It was the example of 3-level laser system. The block diagram of the ruby laser, it was shown in the slide. A ruby is nothing but a rod which was made with aluminium oxide, Al2O3. Now, this aluminium oxide, it was doped with 0.05% weight of chromium oxide, Cr2O3. Then, basing on the concentration of the chromium oxide, the color may be pink or the color of the laser may be red. So, this was a xenon discharge tube. At the center of the discharge tube, we were placed a ruby rod. This was a ruby rod, and one end of the ruby rod is having fully reflecting surface, and the other end of the ruby rod is having partially reflecting surface. Now, a helical xenon discharge tube that was surrounded by the ruby rod. At the ends, a power source was connected, and here at the two ends of the discharge tube, we are making use of the coolants. That means when the ruby rod was heated, an enormous amount of heat energy that was being liberated inside the chamber. So, to avoid the heat loss, here we are making use of the coolants. And here, at the partial reflecting end, the laser beam that was emerges from the tube. When the discharge tube, which was filled with the xenon gas, is operated for several milliseconds, then the ruby rods gets heated, the laser beam that was emitting from the partially reflecting surface. Why? Because on the other end of the fully reflecting end, the laser light, they should not emit. Why? Because it was a fully reflecting surface. All the light beams, they are produced, they comes only from the partial reflecting surface. So, we already seen the construction and the working of the ruby laser. When the flash lamp was on, then the aluminum ions, they are excited, and now the aluminum ions are replaced by the chromium ions. They comes to the higher energy states. After staying for a time interval of 10 to the power of -8 seconds, all the ions, they comes to the metastable state. Let me see the energy level diagram of the ruby laser. It was clear that this was a 3-level laser system. So, this was the lower energy level indicated by number 1, and this was the second level, which is also called as the metastable states, and The third one is a higher energy level. If we give the energy to the lower atoms, then it will reach us to the higher energy level. And now they will reach us to the third energy level. The chromium ions reaches to the third energy level, and from that the excited atoms, they comes to the metastable states by the non-radiative decay transitions. After that, the metastable state, after some time it was more populated, and then the atoms becomes relaxed from this state to the lower energy state by emitting a laser light of wavelength 6943 angstroms or 694.3 nanometers. So the ruby laser, it emits the radiation having a wavelength of 6943 angstroms. But of course we are having several disadvantages while using the ruby laser. Why? Because if we switch on the xenon tube for several milliseconds, then huge amount of heat energy that should be transmitted to the surroundings inside the glass tube. So in order to make continuous beams, it was not happens in the 3-level laser system. Why? Because especially in the ruby laser. Why? Because the heat that was generated inside the glass tube, that may be harmful to the ruby rod. So that's why this was switch on and off process can be followed. So due to these reasons, we cannot produce the continuous beam of laser light by using ruby lasers. So that was the drawback of ruby laser. Why? Because the ruby laser requires the high pumping power, and the efficiency of the ruby laser is very small, and the output that comes from the ruby laser is in the form of pulses. So we cannot produce, we are not able to produce continuous beam of laser light by using ruby. So in order to overcome this difficulty, we are having gas laser, that is a helium neon laser. It was the example of 4-level laser system. In the helium neon laser, a mixture of helium and neon gas that was taken inside the quartz tube. Of course, we can see the block diagram of helium neon laser in this slide. This was a quartz tube, and one end of the quartz tube is closed with the high reflector, and the other end of the glass tube, that was the partial reflecting surface from which the laser beam that was emitted. So this was the laser output, that means the laser light emits from this side. So here if we see helium are having the lighter molecules when compared with helium gases, or having the lighter molecules when compared with the neon. So the discharge tube is filled with the helium gas which was taken at a pressure of 1 mm of mercury, and the neon gas is filled inside the tube under a pressure of 0.1 mm of mercury. Here the helium and neon gas mixture that was taken in the ratio 10:1, the quad tube is having a diameter of around 1.5 centimeters and a length of 80 centimeters was taken in the helium neon laser. And now if we see the energy level diagram, initially the helium atoms are in the lower energy level, and now if we supply the energy to the helium atoms, all the helium molecules are excited to the higher energy levels. So the excitation by the electronic collision can be taking place here. And now inside the chamber we were taken helium neon gas mixture. So helium atoms, after absorbing the energy, they collides with the neon atoms, and now the neon atoms absorbs the energy from the helium, and now the helium atoms comes to the ground level. Now the neon atoms plays the key role in delivering the laser beam. And now after excitation and collision processes, the neon atoms, they are all in the 3s state. They comes to the metastable states, that was 3s state, from 3s state to 3p state, and these are all the non-radiative decay transitions. That means the energy that should be lost in the form of thermionic emissions or collisions, or the energy may be lost in the form of heat energy in the collision process. So after some time, the exciting neon atoms, they reaches to 3s state to the 2p state, and a few among the neon atoms, they comes to the 2s state to the 2p state, and now a specific transition from 3s state to the 2p state, that was called as the laser light, that was emitted from 3s state to the 2p state, which emits the radiation having a wavelength of 632.8 nanometers, and most of the atoms, they comes from 2p state to the 1s state. They are the fast radiative transitions, they cannot emit the radiation, and they comes to the ground level by the de-excitation, which was also called as the diffusion of the molecules to the walls, and the exciting atoms comes from 2p to 1s, and they can be relaxed and comes to the ground level. Here, among all the transitions, the specific transition from 3s state to the 2p state, which was prior, because the laser emission that should be taking place from 3s to 2p region, all the remaining transitions, they are all the non-radiative transitions, they loses their energy in the form of heat or the de-excitation process. And of course, we have several advantages by using helium neon laser when compared with the ruby laser. This was a gas laser and it can emit the continuous laser pulses, and the cost is also low, that was less expensive when compared with the ruby laser. And there was no cooling system was required in this process. Why? Because after collision process, all the helium atoms, they gives their energy to the neon atoms and they comes to the ground level, and the neon atoms are only the responsible for giving the laser light. We are having several technological applications. Basing on the requirements, the lasers having vast applications. So especially in the communication process nowadays, due to the narrow bandwidth, lasers are used in the microwave communication systems. By using lasers, we can also find the distance from Earth to Moon. And at the same time, the lasers are also used in underwater communication networks. Especially the lasers in the industry, we are having several advantages, especially for cutting process or drilling process. Lasers, they can use to blast the holes in the very strong materials like diamonds and hard steel, etc. By using lasers, we can cut and we can drill and we can weld, and also we can remove metal from the surfaces, and lasers can also be used to measure distance to making maps by surveyors. Especially nowadays, the lasers are having several medical applications. What not? After developing the laser technology, nowadays the surgeries becomes very easy. So here in this slide, just we were mentioned a few of them where we are using the lasers in the medicine. Argon and carbon dioxide lasers are used for the treatment of lungs and liver. And new kind of laser surgery that uses molecules to stitching together and bonding together in the surgeries. And lasers are also used in the treatment of glaucoma, especially the carbon dioxide laser, which was used in the spinal and brain tumor excision and kidney stone extraction. Specifically nowadays, the eye treatment, what we call it as the cataract operations, and the removal of the cysts inside the bodies, and the removing of extra blood vessels on the retina, they are all that should be done from the lasers. So here in this laser can be used the opening in a cloudy lens, and especially in the military purposes, the lasers are used as a weapons nowadays in order to chasing the targets and destroy enemy aircrafts and missiles. So depending upon the several technological applications of lasers, just we are giving a few more advantages of lasers. They especially used for cutting glasses and making holes in the ceramic materials, and in order to remove tissues, and they can be used to make operations especially in the medical field. And of course, including advantages, we are having disadvantages. The lasers are also having the dangerous to the atmosphere and health. Why? Because they are all having high intensity. So the laser printers are very costly when compared to the other printers. And the other disadvantage was, when running the laser machine, small amount of ozone are generated which can damage the ozone layer. Some laser particles are also known to emit the particles that may cause respiratory diseases, and it will harm if we make direct contact the lasers with our eye, then it may leads to the loss of our sight. So finally we conclude that the lasers plays an important role in the modern technology, and the laser, after developing the lasers, nowadays they play the pivotal role in the present technical world. Thank you.